Alright, let's go over lesson 1.4, displaying quantitative data, or numerical. We're going to do STEM plots. Learning targets. After this lesson, you should be able to make and interpret STEM plots of quantitative data. So we're actually making a graph, describe the distribution using SOCs, shape, outliers, center, and spread, and then compare distributions of the quantitative data with dot. That shouldn't say dot plots, that should say STEM plots. Okay, so let's go over this one. So what are STEM plots? They're also called stem and leaf plots or distributions. So how do you make a STEM plot? It can be from a single set of data or two sets of data. Let me call that back to back. And are constructed in a vertical column. The stem is the first part of the data and can be a single digit or multiple digits. A leaf is the last part of the data and must be a single digit. The plot must include a key. Alright, so let's go to example number 1. This data represents the responses of 20 statistics students to the question, how many pairs of shoes do you have? So if I ask you how many pairs of shoes you have, and this is just a bunch of numbers I have, let's divide this up into 4s here. Alright, so what are we going to do first? We're going to get the stems. And if I notice that the stems are, if you look at all these numbers here, for example 13, that's in the tens. So my stem is going to be these numbers. Now it is possible that you have a single digit, so I'll put a 0, and what's happening here is that these are actually multiplied by 10. So this is the stem. Stems are this part here. Right, if you go outside to the tree, the stem is kind of like the line that has all the life to it. And then number 2, we need to add, try that again. We need to add leaves. So basically, if I have that structure there from before, I have 0, 1, 2, 3, 4, 5. And then to add leaves, I'm going to go through the data. And remember, check off the numbers as you're doing these. Super important because you don't ever want to miss out on a number. So there's 50. 26, 26. Pay attention. You're not writing the 2, you're just writing the 6. Because this represents 26. Now if I write another 6 here, this does not represent 266. That represents 2 digits in the 20s. There is 31, 57, 19. And you're kind of doing what we did last lesson about dot plots. You're trying to actually make the size of this number and its width, like how big you're writing this, actually be the same size. That is super important. 24, 22, 23, 38, 13, 50, 13, 34, whoa. I lost track. 50, 26, 26, 31, 57, 19, 24, 22, 23, 38, 50, 13, and then I'm doing 34. So 34, 23, double checking that I should have two 23s, 30, 49, 13, 15, and 51. Okay. You can also double check by counting. You should have 20 statistics, and if you count, there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and times 2 is 20, and then you just count each of the blue numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Uh-oh. See, I missed a number. I have 3 13s. So the order doesn't matter because on number 3, we're going to order the leaves. Order leaves. So again, here's my stem. And this blue here is the leaves, and I'm just putting them in from least to greatest. So in here, I have 3, 3, 5, 9. You're going from least to greatest. And then over here, I have 2, 3, 3, 2, 3, 3, 4, 6, 6, 4, 6, 6. And then I have 0, 1, 4, 8. And then I have a 9, and I have 0, 0, 1, 7. Okay, so there is the ordering of my leaves, and then lastly, I need to add a key. So 4 steps you need to do for a stem plot, or they call it stem and leaves. So for example, let's take this one right there. For stem 9, what does this represents? A student reporting to have 49 pairs of shoes. Or you can say that the stems are the 10s. So here is the stems in pink here that I'm highlighting, because remember we said you're multiplying those by 10. And then the leaf, let's try a different color. Let's just do white. The leaf, what I'm going to circle here in white, these are 1s, right? So that would be 50. Okay? So review, make the stems, add leaves. Number 3, order the leaves. And then 4, add a key. All right, let's go on to the next page. All right, why don't you go ahead and try this one. Go ahead and try example number 2. You're going to do the same thing, make a stem and leaf plot, and then answer those questions. And then press play for solutions. Or if you want, you can just do it with me. All right, let's go ahead and go through this problem. Make a stem and leaf plot of algebra test scores given below. So what am I going to do? I'm going to first make my stem. There's my stem. Then I'm going to survey the numbers. And then I notice that all of my numbers, the lowest number, if you look at all of them, are in the 50s. So you could have started with 0, but I'm going to start with 5, 6, 7, 8. And I do see numbers in the 9s. Okay, then I'm just going to next add the leaves. So now we're going to add leaves, and I'm writing here in white. So 56, 59, 64, 65, 69, 70, 71, 73, 76, 77, 78, 80, 82, 82, 85, 86, 91, 91. If you notice, all the test scores are going up, so they actually put all those test scores in order for us. 92, that's not a 2. 92, 92, 95, 98, and 99. Okay, let's go ahead and answer these questions now. So, stem, add leaves. Are they in order? They're already in order. So I don't have to do anything. And then fourthly, what do we do? Key. No key. Gotta make a key. Put a key. So what's my key? You can look above what we did. So you just take any number. Let's just take, change colors. Means the student scored a 70 on the algebra test. Or you can say that the stem is by tens, right? Over here, this is the stem in pink, and you're just really multiplying that number by 10, so that represents 90 and 91. And then the leaf in white, those numbers represent ones. Okay, let's answer these questions. What type of graph does a stem and leaf plot represent when turned vertically? What type of graph does a stem and leaf plot represent when turned, I think they meant horizontally. Let's see if I can do this. Copy, paste, and can we turn it? Can't turn it. No. No. We can't rotate it, so we don't need that then. Turn your head sideways. What kind of previous graph does that actually look like? Circle graph? Dot plot? Kind of. But more specifically, it should look like a bar graph or a histogram. Histogram because it's actually because the numbers are touching. That's the difference between a bar graph and a histogram. So if you turn your head sideways and make this pink here like a horizontal line, so that should read horizontally, what do you have? You essentially have a distribution or graph that looks like a histogram. What's the lowest score on the algebra test? Look for the minimum, or the smallest number. Well, if you, not cheating, and that's why we organize the data, you can look through all your raw data over here, or just look right there. 56. What is the highest score on the algebra test? Well, the 50s, 60s, 70s, 80s, 90s, and you look over there, you have this number, so 99 is the largest number. In which interval do most students score? The interval has a start and an end. Back in algebra, we use not this interval notation, right? You would have something like this, like 1, 3 parentheses, or maybe do something really complicated like negative infinity to positive infinity. You guys remember that? Well, anyways, an interval has a start and an end. So what is the smallest to biggest? You just use the numbers to them there, but I didn't really carefully read it. It says the most. Where is the most numbers occurring? In the 50s, there are 1, 2. So there's 2 here, 3, and you can just look at the height of them, right? 1, 2, 3, 4, 5, 6. There's 6 numbers there. 1, 2, 3, 4, 5. And of course, 1, 2, 3, 4, 5, 6, 7. So if you just turn your head sideways, you could have seen that the 90s has the most. So how would I answer the question, which interval did the most students score? Is it in the 50s? No, there's only 2 tests. How about the 90s? So you can say from 90 to 99. Okay? All right, let's try the next problem. The data describes the number of shoes in their closets. Create a blank or back-to-back stem plot. Here, what you can be doing is, they can also call this splitting. A splitting stem. Splitting stems. Okay, so if you think about it, you're going to actually put the females and males, and you're going to have the stem right in the middle. So I'm going to have, now the splitting of the stem, you can do something. So number 1, we're going to create our stem. I'll show that without what part comes in first. But normally we have something like this, right? 0, 1, 2, 3, 4, 5, 6, 7, right? But most of my data is between the numbers 0 and 5. So splitting refers to taking the 0 and making them 2 zeros. Go away. I don't know how to make that thing go away. Don't do that. 5. Okay, so what does that represent? This is going to be like the numbers 0 to 4. And this will be 5 to 9. And this will be the 10 to 14. All right, so let's go ahead and write our... And I'm only doing this because there's too much data, too many number pairs of shoes in the tens. 3, 3, 4, 4, 5, 5. So again, this side represents our females. Got a key. And then I'm going to look and just go through this and just list my data. So 50. Okay, this is going to be kind of weird, okay? Because females are on the left side, you write your 0 here. But this does not represent 0, 5. Remember that 5 there represents the tens. The stem represents tens. So 50, 10 times 5 gives you 50, so that 0 represents 50. 26. Okay, so again, this does not represent 62, represents 26. And remember, we split the stem, so the first two there represents like 0, 20, 21, 22, 23, 24, 25, and then this one has the 6s. So I have two of those. 31, 57, remember that's on the second because we're splitting it. 19, it's on the second one, not the first one. 24, first one. 22, 23, 38, 13, 50, 13, 34, 23, 30, and 49, 13, 15, and 51. So that represents the females. Press pause or continue with me. We're going to do the males. So let me zoom in on this side. 14, 7, 6, 5, 12, 38. So again, we're splitting the numbers because we're trying to organize our data. There's so much data in there that we can actually split the stems. So the first number you see, like this 3, represents the 30s. 30, 31, 32, 33, 34. And then the second 3 here represents 35 to 39. 35, 36, 37, 38. 8, 7, 10, 10, 10, 11, 4, 5, no, 5, 22, 7, 5, 10, 35, and 7. And the big picture here is, when you get lots of data like this, you kind of want to display it and be able to quickly show your readers or whoever you're trying to convince of your information. And then think to yourself, the last thing that we are missing here is our key. So our key represents 4 stem 9. This represents a student who has 49 pairs of shoes. 49 pairs of shoes. Or you can do the other one where you do the stem and leaf and then tens and ones. All right, what I want you to do is go down, last example, you do it yourself. Heights of high school students measured in inches, create back-to-back STEM plots. Make a decision. You can press pause and try it, or you can work alongside me, but make a decision. Should we split the stems or not? All right, let's go over the last one. So I'm thinking to myself, looking at all these numbers, and I see most of the numbers in 70s, 60s, and 50s, so I'm going to split the stems. The question is, how much do I want to split them? And there is no right answer here. What you're trying to do is convince your audience of something. So I don't notice a lot of numbers in the 50s. So let's use, let's just try it. 50, So that, again, the stem there represents the 50s to 54. The second stem of 5s represents 55 to 59. This represents 60 to 64. That one represents 65 to 69. This one represents 70 to 74. And this last one represents 75 to 79. So let's go through our list. Let's do females. And let's do our list. 60, 59, 62, 59, 66, 65, 60, 62. Again, try not to cross off the numbers because you actually want to be able to use these numbers again for any reason. You want to be able to see your data. 68, 63, 58, 64, 64, 65, 62, 61, 62, 61, 61, 60. And let's go ahead and over here get our males. So 61, 63, 65, 65, 64, 64, 66, 69, 72, 67, 70, 65, 74, 64, 60, 70, 68, 63, and 68. Okay, when I look at these numbers, you write a key. Let me quickly do that. Key 8. Now I'm going to show. I haven't shown this one to you before, but I'm going to show that if the stem is on the inside, and then the leaf, let's say going this direction, right? So like that number right there, that represents a 58. And then our leaf, was in our stem, which is inside, remember that's times 10, that actually represents 60 inches. So you can note which side, left or right side, based on where the number is, okay? Now, you could have done something else, and I just, I'll show it to you in a second, but I wanted to show this, that you can still use socks. In the last video in dot plots, we compared the shape, if there's any outliers, where's the measure of center, and how is the spread. So you can still use that. So what would happen if you decided to split the stem even further? Okay, what does that mean? So you can choose, if you notice that all the numbers are in the 60s, and you can choose 0 and 1s, 2s and 3s, 4s and 5s, 6s and 7s, 8s and 9s. And if you do that, and you took your female heights and your male heights, and you did your back-to-back stem plot, splitting more stems made it, I think, a little bit more obvious that the female heights are more in the 50s and 60s, and the male heights were in the 60s and 70s. Our graph that we created on my black screen didn't show that as obvious. So splitting the stems can make your point. So maybe you're trying to say males are taller than females, and then you would split more stems to kind of prove your point. So you're kind of using data and graphs, visuals, to prove your point. If you were on the previous black background screen, if you're trying to prove that females and males are pretty much the same height, I think you kind of see that on the graphs. And again, if you turn your head sideways, you're going to kind of see in some ways a dot plot or a histogram. So that was lesson 1.4, creating STEM plots.
Love math. You don't love math? What's wrong with you?